Hi, this is Wojciech.
Hello, this is Michał.
And we've done this one thing that some people say shouldn't be done, which is basically grabbing 10 new people during their university and education, and we taught them Lisp. And then we put them to work. So yeah, first of all, a little bit of context about our company, what we do, and what context our interns were put into. So a short description about Keepit. Basically, we do cloud backups for companies, which is a very, very short description of everything that should be said. You have some sort of services, which is like Microsoft 365, Google Workspace, Salesforce, Jira, and everything like that. And you have a lot of people using it, 20, 200, 2000. They basically generate a lot of data, a lot of stuff. And you want to be able to have a copy of it. You want to be able to browse it. You want to be able to restore different versions of this file. For example, this email from half a year ago, or this file from yesterday, or this exact same file from a year ago, and so on and so on. This is basically the main use case of Keepit as software. And as I said before, there are multiple cloud platforms that are supported. Keepit is working on getting more and more under its umbrella. The idea is that if your company uses one of these various services for whatever part of their business, we want to be able to back it up and restore it so that you basically have one more copy of your data for the scenario, unlikely but possible. What if Google just decides your company does not exist? At this point, well, you might have all your data in Google. That's one place you no longer have access to. So what if you have another copy with various snapshots of it in time that you actually have access to, that is set up externally outside of Google services, and so on and so on. The idea is that we do daily snapshots and incremental ones. So basically we check if the contents of the file and the metadata have changed. If they haven't, and we already have a copy of this file, then we do not re-download it. We only do diffs. So yeah, that's a daily incremental snapshots. We have some analytics and insights into the data itself. So other than size, you can also check some other informations about the data that you are downloading, and some control over data restoring and the permission system of who in your company is allowed to do what with the data. And also all of this is browsable. You can actually inspect it as if it was a file system of some sort. Okay, Wojtek?
Right, so this was the what. Now let's talk about a bit about the how. So this is the high-level overview diagram of what we actually do. I won't keep you long with this one. Let's just move to a list of components. So, going from the outside in, from the outside world towards the inside of our system. The outermost interface to the world are so-called cloud connectors, and these are basically service-specific. So whenever you have some particular service, we need to have a cloud connector that understands its public API, and then that can actually handle some of the routine operations, like detecting that a file was added or deleted or modified. Then we have a component called Object Store, which is actually like a homegrown file system object store, which stores the data itself, and also which serves as the source of information, of analytics information, and of some sorts of metadata that we produce that end up in bsearch, which is our search engine that allows you to actually go through the contents of the backups without doing a full restore. Now we get to the more interesting, from the point of view of this crowd, components, the ones written in Common Lisp, which is simport, short for search import. This is a tool that actually runs routine importing cycles, and by doing differential analysis of snapshots, decides what should end up in bsearch. And there's the all-encompassing component business logic, short buslog. This is the central, probably the most important piece that actually orchestrates the entire system. And it's also probably the focus of the heaviest development efforts, and also an important part, conceptual part for what we did with the interns. And on top of that, we have a proxy server which handles routine proxy stuff such as redirection, authorization, and so on. Plus some transform caches which actually store pre-generated files like reports, invoices, and the like. Right, so maybe let me just quickly come back to this for a moment. So the Lisp parts, as is fitting, are at the center of this picture of the universe. Here's another diagram that shows the similar thing, but from a different point of view. So this is a rough idea of data flow. So there are basically two directions of data flow in our system. One thing is the user-centric data flow. So there is a user. This is the end user. They typically operate via some kind of graphical web front end, but this might also mean homegrown integrations with our system through our published API. Stuff gets redirected through proxy. There's a channel of communication with the transform cache. There are some requests going to the business logic and also to bsearch. And these actions can result in some changes happening in the object store. 3, by the way, is version 3. So there were two previous less successful instantiations of this one. And another track, another path that data gets into our system, which we, for the benefit of this diagram, we called ingress flow, is stuff that gets initiated through events in external cloud services, like file creation or file modification. So as briefly mentioned before, data of this kind enters our system through cloud connectors, ends up in OS3, and then undergoes various iterations of importing, re-importing, indexing, and the like. OK, so since this is the Lisp conference, the obvious question that has to be asked, and that we ask ourselves, and people before us did as well, is why Lisp? So I don't think we need to preach to this crowd the benefits of Lisp, but let's just go through it for the sake of formality. So what we needed, and it's an extended we the company, was stability, both past and future. In particular, because at the time the company was set up, roughly 2012, for a technology to be seriously considered, it had to have had at least 10 years of stable deployment of fairly mature tool chain, and also prospects of not going anywhere in the next 20 years, which I think, yeah, commonly fits the bill. Predictability in terms of behavior, runtime performance characteristics, and so on. Mature tool chain, good understandable compilers, predictable paths of code optimization, good performance, and probably the most important thing from our point of view, especially in view of certain tasks that we occasionally have to deal with, ease of debugging, introspection of the whole thing, the ability to hot patch things, to essentially debug in production. And how do we actually use Lisp, and which Lisp? We use SBCL because it gives us a good compromise between it being actively developed, it being open source, and actually being mature enough and predictable enough for our needs. We use a bunch of open source libraries. Probably the most important of those are Postmodern, Local Time, Bordeaux Threads, usocket, Trivia, 5am, CLPDF. There are a couple more, but these probably handle the most important day-to-day responsibilities of the system from the outside. We also have a bunch of in-house libraries. There used to be, and there still is, a certain amount of bias against importing external things in the company. That's why we have a homegrown XML parser. That's why we have a homegrown HTTP server client, our own job queue, our own SMTP client, a metrics subsystem, and some other things. Right, so this whole thing, this state of thing means that we need Lispers. And as you probably know, Lispers, especially Lispers who fit an intersection of certain requirements, like maybe being available locally, or like maybe having a good availability in terms of hiring and enough experience, are hard to come by.
There's not a whole lot of us, basically.
Yes. So, having probably almost exhausted the local pool, and by local I mean local around Kraków, Poland, having hired first Michał then myself, we started.
Actually, okay, this is a little bit unfair. There were some other people getting hired along the way, but yeah, maybe I will take it from here.
Okay, go ahead.
Yeah, the thing is that at some point, Kipit opened an office in Krakow and started hiring Lispers over there. I joined, then some more people, then Wojciech, then some more people, and at some point, we started noticing that our positions for common Lispers in Krakow or in Poland, since Wojciech is not local to Krakow, have not just been really answered. There was an intersection of people who had the necessary competences or were willing to learn them, and the people who fit the company constraints, which is basically being located in Poland or best in Krakow. There were just not enough Lispers who already knew the language to hire. So yeah, there was the problem of us running out of people to fill in the positions. So yeah, we had the idea, hey, what if we actually did the crazy thing? We grabbed some people who don't know Lisp and we taught them. And we basically rolled the idea a little bit back and forth as a joke until it stopped really being a joke at some point, because it was considered seriously. We talked about it with the management up there, and at some point we figured out, hey, we might actually get it to work. We got it to we got to work with it as an internship program where we figured out that the length of it would be longer than the usual 3 months, because basically we would probably take 3 months just to teach them the language and then needed some more time to get them into actual company code and so on. So we figured that the optimum would be 5 months. So we ended up with 5-month-long Common Lisp internship, so opened the positions, sent out it all around Poland, and yeah.
So the first moral of the story before we even get started is be careful what we joke about.
So yeah, we posted about it on several job boards. We had a publicity event describing Kipit and just, letting the world around one university in Krakow, Jagiellonian University, that we as Kipit exist, we are hiring Lispers, what our overall idea and architecture is about. Then we got, quite a lot of resumes, since the job offer was basically come up with whatever skills you have, we will screen you, we will check out what you can do, and then teach you everything you need to, which is kind of nice. I mean, if I were applying for an internship, it would be nice, I guess. Then we did the resume screening along with people at the company and come up with a programming problem, which was not really meant to be a problem, since in this case we were not looking for any particular set of skills, like programming skills, since, we cannot be looking for Lispers if you know Lisp very well, but we don't expect for you to know it. We basically invented a problem that had a pretty simple, obvious solution. And then a lot of complications and a lot of, gotchas when it's scaled up into real-world data sizes. So, for example, it was ransom letter?
Yes.
Ransom letter, yeah. You have an input file. You basically cut out some letters from the input file and check if the, how to say,
Basically, the task was to verify whether, given a source of letters, some kind of string, and the desired text, whether you can actually compose this text of those letters. Simple enough when you think about just getting the job done, but with some nuance if you want to actually have talking points with people.
And yeah, we got a lot of pretty simple, obvious solutions, which gave us exactly what we wanted and needed, which was material for actually talking to people. Because what happens with your program when your input size is, how to say, 25 gigabytes of size, size of the English Wikipedia, I guess. And basically, this was one of the starting points, plus some algorithmic complexity, plus some data structure questions, plus, and so on. Basically, it was more of a, how to say, more of a way to provoke people into thinking and answering our questions so that we could figure out what works inside their minds than a real programming question. It was because we did not really screen for any kind of existing knowledge, but the potential to develop it, since we would be teaching them everything they needed and not look for something that already exists.
And actually, for precisely this reason, the few solutions that came in, which were kind of like bulletproof and already good, were a bit of a disappointment because they robbed us of the opportunity to poke into them. And we specifically wanted to see the gears turning. We wanted to experience the thought process, how people react to difficult questions asked at the spur of the moment, and how they deal with stress. Which, yeah, we actually at this point we also wanted to see how they do spoken English communication, because we viewed them from the very beginning that they were. It would be obvious that those who stay are going to join existing teams of English-speaking people, and if they were to hang up on words and get bitten by stress too much, it was a no-go. And we actually, regrettably, we had to discard certain people because of this.
So yeah, once we did the screening, like the 2 layers of screening, first of all the CV one and then the programming one, then we invited everyone for interviews. Some of them were in the office, most of them, I guess, were at least partially remote. And yeah, we basically stressed more or less everyone for about an hour, some people a little bit less, some a little bit more, but afterwards we ended up with 10 people that we wanted to hire, and we hired them. So yeah, then once we did the hiring, it was actually before we wanted to teach them Lisp, we had to teach them the basics of Emacs, since we wanted to use Emacs along with Slime as the IDE of our choice, and I think Wojtek did most of the work over here.
Right, so we had to start with the hard stuff, of course. We were considering for a moment to use VS Code combined with Alive, but we did not have ourselves enough experience using it. Nor did we have conviction that it will actually do the job. Also, most of our existing, all of our existing Lisp force uses Emacs, so we found it only natural to start with this. So we started by setting them onto the built-in tutorial, and then ran some we actually worked with them, developing some basic configuration. Our point at this moment was to have something, just the bare minimum running, something that they could, having spent a couple of days learning it, conveniently approach as BCL, do stuff in the REPL, and not get their efforts hampered at this moment. Later, this became a kind of an invitation to actually start to try living inside Emacs and doing other things, showing them that you can. It's not only an editor; it's actually a decent operating system in its own right. Many people picked that up and actually became quite both excited and adept at using it. We also had the problem of picking a particular flavor. So we had a mixture of backgrounds and preferences here. So I use vanilla Emacs most of the time. Michał uses Spacemacs. There were some people interested in Doom. So what we ended up doing, we basically ended up multiplexing mentally between different Emacs distributions, which was pretty good, I guess. Right, and then, so this part took about a week, I would say. The hot part of it, the intense part of it. Of course, the teaching process is not complete, not even today. But then we had to move to the thing that this internship was about, which was the Common Lisp part.
Which was actually Common Lisp, yeah. We started and ended up using Practical Common Lisp, which is a book that is 15 years old, which is pretty young by Lisp standards, and which is surprisingly useful even today. Like, I don't think there are many parts over there that have become outdated whatsoever. At least I haven't noted any. Plus, we ended up needing to multiplex for people just coming in and out at various times, since basically we promised them that we wouldn't interfere with their university duties.
Too much?
Too much, yeah. They were basically supposed to be in the office for 20 hours a week, and they were, how to say, free to allocate this time however they wanted. So we started with the approach that everything needed to be as asynchronous as possible. So every single Lisp session that we held, we recorded using, sadly, Microsoft Teams. And yeah, everything was with screen share, and everything that wanted some kind of visual display, kind of a virtual whiteboard. We actually decided to use a drawing program to describe all the various questions that needed to be answered graphically. Let me check if I can very quickly. I think, yeah, basically there was a question, hey, how does the type system work? So yeah, basically, if you have something like bit, then you have something called fixed num, integer, and this goes into this, integer goes into this. Everything then is of type T. There is also array, string, everything, blah, blah, blah. There is the empty type nil, there is the type null, everything like this. Basically, we ended up doing using the drawpile program for everything that needed any kind of visual representation. We used layers over here as a notable thing. Basically, if we wanted to draw something over something else, then make it disappear, blah, blah, blah. It was surprisingly useful for when we wanted to actually go for something that needed to be recorded and then replayed sometime else. Yeah, that's the one. Then we did a little bit of homework exercises, which were pretty simple in the beginning, like, hey, you have this function, you have this function, you have a little bit of console wrangling. Can you write a function that, for example, reverses a list or flattens a list, something like this? And here is one lesson that we learned very early. We should have been we should have been doing this straight from the start and not how to say, a month in, because we started with theory for about. We've been doing Emacs configuration and theory, as in going through Practical Common Lisp with sessions describing the different aspects of the language for about 1 month. With very little homework, we should have start away with it, and this was one of the pieces of feedback that we were given.
Right. Okay. The other, you could say, complementary part of the Lisp instruction was a happy coincidence that just around this time, another batch of another edition of Advent of Code was starting, and already before this idea came up, some people were expressing their intention to take part in it. So we actually made it. We actually made an optional additional recording sessions of solving problems. And this was a very good excuse to actually have wider computer science-related discussions, and showing particular algorithms, discussing complexity, comparing various kinds of approaches to problem solving, and it proved to be quite popular and actually got quite a few people engaged in it, including some people from outside the internship. Right. There was also another part where when we, and actually Michał, developed basically a skeleton, a class-based skeleton for a role-playing game, which involved well, things you do at work, like hitting monsters with weapons. This was a more practical introduction to class, because before we referred them to practical Common Lisp and did some conceptual discussions and also some live demonstrations. But this, I think, was the first example of actually doing something with a backstory.
A little bit of context, we also needed to teach some of them the basics of object-oriented programming along the way, since basically they were not yet at the university level where they practice it. So our internship was like this, where we taught some Lisp and also some general programming concepts. There were some data structures and Linux lessons along the way as well.
Yeah. So we figured, yeah, it's all fine and dandy to speak of class and talk about classes and method hierarchy, methods combinations as well, and so on. But it would also be nice to actually give them something concrete to think about. So like some kind of anchor, so that they know why they are even doing it. And well, since most people like games or some kind of gamification, we just gamify the problem, literally. And having put in some work in joint live sessions, we also invited them to extend this mechanism according to their own whims. And this is where we were pleasantly surprised that people actually displayed a tremendous amount of creativity and creative freedom by coming up with all kinds of wild ideas.
And yeah, one of the further tasks that we have decided to give them was, how do we give them the idea of working with Lisp in production and actually going for the live debugging interactive experience? There was the question of, hey, you have a running system, you might not even have the source code for it. How do you actually go in and hopefully not break stuff, but fix stuff? So there is this idea of capture the flag from OSINT community. We decided to change it a little bit into something called an egg hunt, which is like an Easter egg hunt, except you are searching for eggs inside a Common Lisp process. The goals were to acquaint them with a live debugging, because basically we gave them a Lisp image, told them to run it, did not provide any source code, and just, told them to look for some sort of eggs, which were just specially constructed strings, and check if they were able to find them. And the rules were that you have the image, run it, you have no rules afterwards. Basically, whatever technique you use to find them is going to be good, and be creative, debug, disassemble, inspect, blah, 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 and so on. Also, this was done to solidify CL knowledge, since some of the eggs were based around various aspects of Common Lisp, like
restarts, conditions.
Restarts, conditions, control flow, dynamic variables,
nature of symbols.
Nature of symbols, blah, blah, blah. Basically, all the various quirks of the CL standard that are hard to teach in any other way. A little bit to develop self-reliance, since basically everyone got this task and was asked to not
spoil the fun for the other person.
Yeah, basically, it was not really about cheating, since we did not really stand above everyone and check how they work with it. But the idea was to not spoil the learning process for everyone else. And yeah, there were a lot of documentation facilities, not really just documentation. There was the debugger, the inspector, the documentation function, also the hyperspec or NovaSpec, which is available nowadays. And they had to use a lot of it to figure out how the language works in order to not ask too many questions, because they were, of course, able to ask questions if they got stuck, but the idea was to do as much as possible whenever they could. To create a data point for our evaluation afterwards, because me and Wojtek, as the authors of the internship, also had to evaluate everyone and to figure out if they were good enough to stay in the company afterwards. And yeah, the last point, to have fun while doing it, because we are already teaching them a foreign language and using their trust that this process of learning this language will be useful for them afterwards, like in their future employment history, no matter if it is at Keep It or elsewhere. We wanted not to break this trust in any way.
With this egg hunt, probably more than with other things, we really wanted to drive home the point of explorability, because we started telling them by showing them Emacs that, well, you have this tool here, it's self-documenting. What does it mean? It's explorable, it's modifiable, and initially, just as it did for me when I was learning Emacs, it didn't really make much sense until I saw some of the underlying mechanics. And I think it also served the same purpose with them. They were able to actually see a live Lisp system with insufficient information, poke at it, and in the process sort of gain the understanding that there are things you can learn without being told by external parties.
And yeah, basically you should be able to see my Emacs session with the egg hunt running. The entry point is basically start, which should produce a message. Yeah, basically a lot of information. Be creative, describe the bug, disassemble, rebind, redefine, blah, 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 blah. If you break the image, just remember all the eggs you have solved, and then call verify, which lists all the various eggs that we have created. All of these names are, well, I invented most of them, so apologies for that. I think two of them, let's go for them. Some of the challenges were actually silly, like there are no Easter eggs in this function. Sometimes you just need to be insistent. Come on, this mafia goodness, it's been a while. Yeah, sometimes doing the same thing over and over is not madness. Let's verify this one. And yeah, the no Easter eggs here has one egg less. There is one other egg over here, but let's keep it for now, and not what it seems. Some of them actually needed some Lisp knowledge, like not what it seems, what does this function produce? It certainly looks like a symbol, so the type of this value will obviously be a symbol as well. Except if we describe the value of not what it seems, we end up with a standard object with the value saying, please do not break print read consistency, because this reads as a symbol, but is not, certainly. So if now we verify this, it's going to work, and this one has one egg less. So let's once again describe this. This is a standard object, okay. Swung, inspect in Emacs, not what it seems. Okay, it is an instance of a turbo special class, blah, 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 blah. Okay, so here we have something that is called a turbo special class, okay. Let's also inspect in Emacs, find class of this. But also please look in the class definitions, you know.
10 more minutes.
Yeah, we can verify that one, and so on and so on. Yeah, this is basically a spoiler, and 34 eggs of this nature remain. Some are meant to be fun, some are meant to be quirky, some are meant to be frustrating. That was the idea of going for this.
And actually, much as I would like to take partial credit for it, this was entirely Michał's idea.
Oh, come on. And yeah, basically, this is one piece that me and Wojciech have decided to publish. So this is available. Yeah. This is available on GitHub right now. The licensing part is still going on, so please give us a moment. But basically, if you want to go for it without a lot of spoilers, I think there is a scary warning in here at some point. Yeah, beneath here, spoilers lurk. You should be able to just load it. Load, not compile, otherwise the disassembly contains way too much information and you might be able to accidentally spoil the fun for yourself. Yeah. So yeah, afterwards, this more or less gave us 3 months of actually teaching Lisp, and after these 3 months, we were left with 2 more, at which point our interns were capable of getting some work done inside Keep It.
Right, so because this was essentially an internship and we didn't want them to only have fun, we had to do some work as well. And actually, this started with an architecture overview. There was a drawing session, as usual, where we described all the components and how they relate to each other, how data flows within it, what's the rationale behind behind the various components of the system. We did some code walks with them, describing both high-level code organization and also some more interesting low-level details. Along the way, we discovered a need to actually cover some external tools like Git and SQL, Postgres to be precise, and also introduce them to some of the tools that we use company-wide, like Jira, GitHub, GitLab, and Confluence. Right. Around this time, also, we started defining and actually distributing some of the first real-world programming tasks having to do with our system. So we prepared some tasks, randomly assigned them in groups first, and then later more solo, more independently, to work on stuff such as simple refactors, bug fixes. This was interesting both from the point of view of solidifying their knowledge of the system, but also from kind of establishing a precedence for working with other team members and with other teams. Because until that point, they had been pretty much isolated from the rest of the company, and the rest of the company was becoming curious, so we satisfied their curiosity. And we also, at this point, we started like regularly practicing our software development process with them, like creating merge requests and getting reviews. And yeah, and here you have a quick month-by-month overview of our curriculum. We largely were able to stick to it, sometimes maybe manipulating moving certain topics across month boundaries. And we did this for, well, both for ourselves, but also for the sake of accountability, because we had people above us who wanted to know what we are doing and what the time scale of this thing was. So to wrap up, we ended up with 10 hireable candidates.
Which is basically lucky. We didn't expect that, like initially we thought that maybe 2 or 3 people would be a success, and we ended up with 10 of them that we would want to hire for various reasons. Some of them being programming skills, some of them being soft skills, and most of them had how to say, a different balance of all of them. But basically, we didn't end up having someone who gave us any red flags, and we wanted to basically kick out after or during the internship.
Yeah, despite our recommendation to keep all of them, we were able to retain 6 people, which was also a success given our previous, our initial expectations.
Or in other words, if you are looking for a Lisper in Poland, please give us a hint.
Yeah, and the lucky, happy outcome was that we now have 6 new junior Common Lisp developers at our company. And some of the lessons learned, just to recap: hiring is hard, but it pays off. The process is surprisingly exhausting, especially if you're not used to it.
And if you're having like 5 one-hour-long meetings, one after another, just to hire people, it is exhausting, really.
It is, yeah. Another thing is teaching is also hard. But it also pays off.
We kind of had the approach of basically stopping and answering all questions whenever they arose, even if it meant basically taking half an hour detour for everything.
So is giving a damn. It's also hard, but it also pays off because in the process we got quite emotionally invested in the whole thing, but it also meant that we took some satisfaction out of it, a lot of satisfaction out of it, despite or maybe because the sense of responsibility. Another thing is we were explicitly aiming for the right mixture of technical acumen and interpersonal skills. Neither of those alone wouldn't cut it. 5 months. It was long as internships go, but remember that we had to teach a whole programming language from nothing, basically. It turned out to be sufficient, but it was stretching the constraints a bit. Final takeaway, improvise locally, but plan globally. This is what we did then, this is what we did with this talk. Maybe it worked. And exercises and homework, yeah, start right away. Do not hesitate, do not wait until they have enough theory behind their belts. And also, be prepared to find that people are actually learning and solving problems faster than you expect them to. And also, prepare work for them ahead of time.
There is one topic, one slide back, please. We have created some tasks for them and expected these tasks to basically take them 2 weeks or so, and they solve it in 2 days or so. And then we also had no more work for them, and the last month of the internship, the last 2-3 weeks were basically really slow. We should have prepared more work for them, and we are running out of time probably, so.
You are out of
Shit, thank you.
We only have time for one question. It has to be short.
Yes, Christoph.
Do you expect to do this again?
Yes.
We hope so.
Short answer, yes.
Excellent.